Well, let's get out the book of knowledge here. So I got to call a guy that's got RO number 24. So we're going to skip over him for a hot minute. We're going to go do RO number 25, 26, and 27. We're going to do 3 in one video because they're all for the same customer. Well, technically 2. Let's start here. This will be a fun place to start. This, he sent it up with an RO number attached to it, but this guy is super cool. Been having fun talking with him on and off. This is an old school messenger. Somebody has gone in and murdered this, for a lack of a better way to describe it. We'll start up here on the face of this thing for the moment. Let's go in here and we'll take a look at this. So it's got a bunch of after-sized LEDs, big old indicator light on the front, extra LEDs here, another LED here. We'll just skip over the chicken poop here in the middle. We'll come back to that. There's an auxiliary plug and another auxiliary plug and an LED and a fuse holder and Romex, and he, in his kindness of his heart, which I think is awesome, we're going to turn this amplifier into a gem. I'm going to see if my friend over at Beard Customs, Mr. Frank, if he'll knock me down a new lid, because this thing's butchered. I'll have him vinyl it like his brand new Texas Star lids. And I'm thinking I might pull the face off on this and weld up this and weld this up and weld this up. Pull the face off, and I'm going to send it down to Illuminati. And I want to send the lid down to Illuminati and have him laser etch this thing and kind of do a crossover video with him. But he donated this amplifier as a Patreon supporting gift. This is an old school M4V. I'm the kind of guy that wants to throw the kitchen sink at it because the bones of this thing are good. Like, I could go in here with a soldering iron and probably within a day make this into a really solid, stout amplifier. The longer I look at this, the worse it gets, though. But it's nothing I can't fix. So don't think I'm discouraged with this, because I'm not. This is going to be fun. We're not going to cover this in this video. I'm not going to rebuild it on this one. This will have to be something that we come back to next year, right? My dance card's pretty full for the next few months. It really is. But he sent this up as a Patreon donation gift to me. And I think what I'm going to do is I'm going to completely rebuild it, customize it out. I'll see if I can get Frank to cut me a lid for the bottom side, and we'll put a couple fans, blow an air down on this. We'll get this thing all polished up, and we'll get a custom Illuminati face for it. We're gonna have some fun. We're gonna make some cool shit out of this. Okay, so let's go over here and let's look at RO26 real quick. Hey guys, it's a 667. Let's see, he wants to do the power wire, max it out. Do my boom diggity to it is what he says. This is a 1 driving 4 667 all Toshiba. So it's gonna need a bath. We're gonna upgrade the key and transistor, upgrade the preamp. Of course, we'll replace and modify the power wire. We'll put new coax in this thing. But first we got to test it. This and the other one. I'll show you the other one here in a minute. His story of him telling me that, you know, he's running this, or maybe it was the other one. I know the other one for sure, but he was running this and it's putting out less power, and he thinks that everything's cool in this, but he wants to make sure. And so we'll probably start on this one, and then we'll do the next one last. The tin on this one's actually in fairly decent shape, so we don't need to call up our buddy over at Beard Customs and get a new 667 lid. Our friend over there at Beard Customs has gone and put out the energy. I'm going to do a separate YouTube video just on that alone. Has gone and put out the energy to produce brand new lids that are thicker and higher quality. He's matched the vinyl, and he's got them for every single kind of Texas Star that there is. The 250, the 350, the 667, the 500, the 400, the 1200, the Sweet 16. He's got them all. And I'm gonna get all those out of the cabinet because he sent me a bunch of test pieces for me to be able to come talk about it on video with you guys, which I think is friggin' awesome. I love that these companies want to come work with me and these people are willing to put out the effort, and I think that it's great because that allows us to continue supporting the Texas Star. Got another guy that's working on 3D printing these, the buttons. This is the #1 called for thing that Texas Star can't support us with anymore. It seems like one day they're getting sold, the next day they're not, one day they're going bankrupt, the next day they're not. Who really knows what the truth is? And it's not up to me to try and determine what the truth is. I'm just here trying to fix the equipment, right? I know that they're not selling parts anymore, and I know that they're severely back-ordered with all of their distributors. That I know is facts. Outside of that, I'm just talking out my butthole. My butt's moving and air's coming out, right? So, but I know from my side of the street, I can't get faceplates. I got a guy working on faceplates. Got a guy now that's manufacturing tins, and then there's another gentleman that was kind enough, and he's in my Facebook group, where he's trying to 3D print the faces for us. So we're coming along on that. This one here, I know something has gone wrong in this box. He said he set this up on his base, and he was talking with his wife and his kid, and he drove like 30, 40 miles away. And while he was talking to him, they just got quieter and quieter, and then he couldn't hear him anymore. This is a Fat Boy in Class C. It's a 1 driving 4 Toshiba, all red dot, 2879s, 1 2879 driving 4 2879s. So something went bad, and they kept running it till it quit. We'll have to check the variable because we got a burned resistor here, and then this resistor pack is discolored. So that is what we're going to do. Let's start with the Texas Star. Okay, so we're going to do as I say, not as I do. Don't ever hook your 667 up with these. This is bullshit, but it'll suffice for us to be able to tell if something's working or not. I can't help but notice that when I turn the amplifier on, the relay gets latched open, which tells me we've got a blown keying transistor. That is a problem. That would mean no receive, so we don't know if the preamp's going to work, but we can check to see if the transistors are good, which is the majority of the concern, being the cost. So let's fire up our old handy-dandy FLIR my job, and let's see here, enter mode, thermal only. Okay. So we can see these 3 hot spots: the relay coil, the bias resistor, the other bias resistor. So let's see if we can talk through the box. We're hooked up to the bench 2950 at the moment. We've got 2 1000 watt slugs in peak there at 0111. We're about 30 watts into it. Okay, I can tell right there just by keying it that quick that all the transistors are good. And we have no issue with the balance combiner. So what we're looking at is this resistor here. We have no at 011111. But what we do have is this inductor getting hot, and the 2 bias resistors getting hot. But all the transistors are turning on. Okay, so we can shut this down. So we're going to do a cleaning job, power wire and coax modification, and we're going to replace the keying transistor, and we'll be back. Okay, so I'm going to break this video out on its own. I'm going to make another video out of this one video. So what we have here, gentlemen, is a Texas Star 667. As those that are watching this in the full form video already know, but the guys that are going to tune in and watch this from the word go, you don't know. So this is a Texas Star 667, 2290 driving 4 2879s. Now I get hit with this question about 4 times a week. And the question is, okay, tell me what's wrong with my amplifier. I plug it in with power, and as soon as I hit the on-off switch, I lose all my receive. And then when the amplifier is sitting there, it gets really hot. But it still makes full power. What's wrong with it? The answer to that is this transistor's gone bad. This is the keying transistor. It's stock. It's a 2N27 or 2907. That's 2N2907A, by the way, to be specific. 2907A. Okay. Me personally, like to use the 2N4125, but I only use ones that are made in Russia. Good luck on finding those. When I run out of those, I'm just going to have to go back to using the regular 2N2125s or 4125s. I like to use them because they work really good in this position over here for the preamp. But I wanted to cover how to repair this because I see this hacked up more than anything else that comes in any amplifier. And I thought, well, this is a good opportunity for me to sit down and document this, bust this out in its own little couple-minute video so that people in the future can look at it. And it also saves me having to try and very painfully verbally describe what they need to repair. This transistor, if you buy it in a bulk over 100, costs you less than 2 cents. Okay? At some point or another, this guy has gotten close enough to somebody else that's keying up power, or the transistor just simply failed because it's literally one of the cheapest parts in the box. And it shorted with the base going to the emitter. So the center pin of the transistor internally is shorted from base to emitter. So it goes collector, emitter, base. So when you go to replace the transistor, you'll notice that the transistor has a little flat side to it. You see how it's got a flat? That flat goes towards this side of the cabinet. You can see it here. There are 2 ways to do this and only one way to do it right. So we're going to cover how to do it right, and then I'm going to show you what most people do, and they do it wrong. And it is literally wrong. Okay? I'll grab my liquid flux. So what I see come in here the most is when they take this to some roadside CB shop, and because they don't want to take a couple extra minutes to do the repair properly, this is what I see. They will go in and they'll cut the transistor off just like this. Then they'll take the new transistor and they'll solder it to the old legs. So then the part's sticking way up here in outer space. So as we can see, the legs have been chopped off. Right here. Chopped clean off. I like to cut the transistor off because it makes it easier to get in there. There are downsides to soldering to the legs. If you have this part sitting up too high, you can bump the amplifier, and because the mass is sitting so high up on the legs that it can fold backwards. If that happens, you can short out against a bunch of other parts, or the legs can short out against themselves. I like to take the time to do it right. It's just me personally, okay? So when I say I like to take the time to do it right, I will cut the top of the transistor off, and I'll get in here with my fine needle nose, and I'll get in here with my fine soldering iron, one of them, and I like to pull each leg out individually. And having a hold of the legs allows me to put less stress on the solder pad. And when you really get into doing this, the solder pad is paramount. I have the soldering iron adjusted to about 425 degrees, and I'm not getting it terribly hot. I desperately don't want to cook off the traces. So I'll come in here and I'll just put a couple little drops of flux. You'll find that the Texas Star circuit has a tendency to get itself a little bit hot. And when it does that, it work hardens the solder and it makes it really hard to use solder wick. So you can do this with solder wick or a solder sucker. But we have to go in. Cancer in California. We'll go in and we heat up the trace, and then we'll pull the solder wick across it. And we're going to remove the solder from both sides of the hole. Sometimes we got to go back and reflow the solder into it, and it's like I said, we might end up having to get the solder sucker out. So we'll go and reflow the solder, make it so it makes contact, and we're wanting to completely empty out the whole trace. Just like that. So we got a nice clean hole now. That's what we want for all three of the spots for the transistor. The downside to not doing it this way is we end up having all kinds of problems down road. So that one I just barely had to touch it. When you go to solder the new transistor in there, if you haven't pulled all the solder out of it, it can push through and drip down and short out on the back side of the board to the case. So we want to clean all three of the pockets out just like so. Now the biggest tip that I can give you, and this looks relatively easy because it is somewhat easy, is the first thing that we want to do is we want to index the feet of the transistor so they're the appropriate angle to make mash with the dangle of the hole, right? So I like to trim the legs back a little bit like this. I'll take this center leg and I kick it forward and then I bend it down. Just like that. So it's kicked out and down. Then I come back and I'll retrim the legs so they're all nice and even. Just like that. Then what I do, let's do this over here where you guys can see me do it. Then what I do is I'll take one of the legs, it's usually this outside one, and I'll ball up a bunch of solder, and I go ahead and I pre-flux the leg, just like that. So then I can put this again in my needle nose because I got big old friggin' meat beater hands. Put this in my needle nose, and I'll come over and I'll take that first leg, and all I got to do is just touch it. And see how that all wicked in? Now we've got control of the transistor and we can put it in the hole. Put that in its hole, and then we orientate the transistor so it's straight up and down. Then we go ahead and we resolder it back into place. Just like that. And we're using just the smallest amount of solder. Because remember, solder into solder vias that go through the board. See how quick that went? Just bing, 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 done. So now that we're done, we can do one other step. This is really important that we do this step, even though most people that do electronics avoid this for some reason. I don't know why. But as I've covered in many YouTube videos preceding me, your favorite thing that you have in your toolbox is 91% or 92% rubbing alcohol. We get in here and we clean all that flux that we just introduced into the circuit. We clean that off with rubbing alcohol. And then we come back with the Q-tip and we scrub it dry. And we do that to keep the flux from being able to make contact with anything in the future, and just in case there's some little ball of something, little ball of schmutz, whatever, we don't have to worry about it being introduced into the circuit and being stuck to anything. But that's the appropriate way to change out the key-in transistor in your amplifier. It takes just a minute or two to do it right. It takes literally 30 seconds less to do it the wrong way. But that's the only way that you should do this. All times you want to be careful not to touch any of the other capacitors or break into the other parts. This capacitor controls your sideband delay. This is part of your sensing circuit. This is your 12-volt choke that keeps the RF from being able to pass. That is the best way to change this transistor. Hopefully this helps somebody out there understand what's going on. And like I said, if you turn your 667 on, click, and this relay activates, and this light comes on over here, and you lose all your receive. But when you turn the amp off, you get all your receive back. 9 times out of 10, it's this key-in transistor. It was working, then all of a sudden you started having this problem. That's the easiest solution, the easiest fix. Okay, so let's hit the test button. And it's telling me red and blue. So here's red. It's attached to this outside pin, blue's in the center. So that tells me that we have a collector to base short internally. Needless to say, we can turn the amp on. Relay's not jumping into transmit mode, and our little grain of wheat light bulb's not kicking on. So the amp's not going into transmit, and it's sitting there constantly in the on motion with our bias resistors getting hot. Now you can turn the amp on, you'll be able to hear, and when you go to key up, it'll automatically jump into transmit mode. Hopefully this helps somebody out there. Hopefully this allows you to fix your amplifier without needing to call me. 2N4125 or 2N2907A. They both interchange in this position. Just saying. So hopefully this helps somebody. All right, I gotta run. You guys have a good day. I can remember about 20 years ago when I first started fooling with these things. Let's see, I would have been, no, it'd been 25 years ago. I was doing mods to these things thinking I was making improvements, and I really wasn't. That's the way it is with life. Then you go forward and you learn a couple things, and you do a couple hundred of these, and then you start to figure out what little parts you've got to change, and it's just 4 little parts that you got to change inside this thing, and then it really takes off and runs. Okay, so we're running on the 2950 on the bench. Let me show you what I'm doing for drive here. Wait a minute. Whoa, whoop, rewind. So, like I said, we upgraded the preamp in here, and we went to that Russian transistor, the, was it 4125? But the thing that makes it special is, for some reason, the Russians spent a little bit more time working on the noise floor capabilities of the amplifier op amp inside this transistor. The quality of the transistor is higher. It's got 9 dBs less noise, so it'll rectify 9 dBs less static than the stock transistor. Okay. Preamp is working perfect. I don't know about you guys, but I'm kind of the guy that I don't believe in preamps. Like, if I need a preamp to hear somebody, I'm probably not going to be able to talk to them back, so what's the point? But if I do have a preamp, I want to have the best transistor doing the job. I mean, call me sentimental or something, but I mean, we did all the power wire upgrades, we did the coax upgrade, we did the transistor upgrade, we fixed the keying circuit issue, by the way. It was all that transistor. It usually is 99% of the time. I broke that out in its own separate video, which is already out. Changed 3 capacitors and 1 resistor. And here's the results. Let's show going through the amplifier first. So the amp is off. It's a 5-watt slug in reverse back to the 2950. At 1111111. Next to nothing in reverse. Let me show the amp. At 111. At 111. That's our input tune. Not too bad. So let's go over here. Of course, we've got our 1000 watt in peak, 1000 in peak, 5-watt slug in reverse. Okay. Show you drive. We're dead keying 1 watt on the money. Ain't no way I'm doing 51 watts. At 11111. At 1111111. To about 35 watts into this thing. Let's turn the amp on. 1 watt dead key gets us a 200 watt carrier. 800 watts plus. Hello, audio. Hello, audio, 1, 2. So we're seeing 800-ish flat here, and 820-ish. Hello, 827-ish on the Digiscale. Okay. As I do in all the videos now, let's flip-flop our elements around. We're not going to touch the meters. We're just going to flip-flop the elements around. And by changing element A to element B and element B to element A, audio. We're seeing 775, and the radio still showing me 60 watts, and that's a lie. Hello, 1, 1. Radio can't do that kind of watts. Hello, 1, 2. Hello, 1, 2. Now with that element, now we're seeing 900 watts peak. Hello, 800, 900 watts out of the 667. This amp will do more watts than it was ever able to do out of the factory. That's a factola. Factola. Let's put these back around the other direction. So let's go and play with the switches on the front. So first we're going to hit the AM button, which brings in a little bit more of attenuator. Hello, 1, 2, 1, 2. Still 800 watts. Hello, 1, 1. Now we're going to bring in sideband. Hello, 1, 1, 1. Hello. About 700 watts out. AM and sideband buttons both in. This will be low. Hello, 1, 2, 1, 2. On the lowest setting, the amplifier now runs like a stock 667. Both the switches out. Hello, 1, 2, 1, 2. 800 plus. All the shizzle dizzles done to this. I think if I would slow down and I'd work on one of these for like a day and tinker with what I know now, we would probably be able to get just a fraction more out of it. But we washed it, we cleaned it, all the lights work. The meter's working. Power wire upgrade's done. All that kind of stuff. Hello, 1, 2, 1, 2. Hello, 1, 2, 1, 2. Preamp is kicking out. Hello, 1, 1, 1, 1, 1. Hello, 1, 1, 1. Done. Okay, amp number 1 is completed. This little bastard will run like there's no tomorrow. Legit. It's got the good coax. It's got Toshibas in it. The only thing it hasn't figured out how to do is, well, give me a rub and tug. And I'm working on that. Believe me, I'm working on that modification. Okay, well, we'll put the tin back on this and let's go jump over to that 1x4. So let's boot the FLIR. Let's turn on our L meters. Amplifier off. 1, 1, 1, 1, 1. Okay. Talk through it, no problem. Waiting on the FLIR to come alive. And then, and only then, can we go ahead and get the beat down boogie on going on. So the story with this, to repeat myself once again, just to fill time as we're waiting for this thing to boot, is that the guy had this thing set up on his base, and him and his son and his daughter, or him and his kid and his wife or whatever were talking to him on the radio as he drove away from his house. And then he got a long ways away from his house, and then something happened to the amp and it quit putting out power. Just thermal only. There we go. Okay, and so just quit. And then it came here. I don't see any burnt 10 ohms, no burnt balance resistors. We'll Turn that 5 watt forward. Overhead can 1 watt. Nope, no, that's not right. There, that's 1 watt. Okay. So let's turn this back around. Let's see what we get out of the amp. Variables all the way open. Output transistors are lighting right up. No balance issues. Man, my phone has not stopped ringing today. Call that guy back. Hello, 1, 2. Oh, this amp's going to work just fine. So we're on 12 volts. 12 voltaires. Hello, 1, 2, 1, 2. We're pulling about 40 amps. So let's reach down here. I'll turn this on. I'll let the batteries catch up for a second in the supercapacitors. And people wonder why I replace these with 5 watters. Look at how hot these are getting. These are 80 something degrees. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Flyback's at 107. 101 degrees. And people hate on me for putting a 5 watt here. And get some test data. Update your files. Learn something. Dumb son of a bitches. All right. Look, this choke's hot. That choke is hot. Imagine that. Oh, look at that. That one's hot too. Imagine that. All right, anyhow, hello, seeing about 900 watts. Hello, about 950 watts out. That's our input. Hello, 111. Input's perfect. Now let's check our variable out. Hello, 1, 2. Well, out of the box, this doesn't present with a lot of problems. Really doesn't, other than, you know, inherent design issues that we've all come to learn about. We'll change this out to a metal clad, or change this burnt resistor. We'll give it some power wire upgrades. We'll change out this long ass piece of 16 gauge, or not even 16 gauge, it's like 18 gauge wire that's feeding the 1-pill driver section. Put a piece of 12 there, and then we'll upgrade this. We'll change out our power wires. I'm assuming that goes to our fan. We'll do the full mounting to it, and I bet you that we'll be up over 1,000 watts before we're done, without a doubt. This tool allowed me to figure out that there are inefficiencies in the box. See, these are still at 85 degrees. Chokes are still hot. Just saying, food for thought. I mean, this is unquestionable data, right? Just food for thought. All right, back down off my high horse. Let's do work. Okay, so where we left off was this thing was making 900-ish watts, if I remember correctly. So if we see 1 watt worth of improvement, then we know that this and this and this and this are all worth it. You know what I should have done is I gotta change that balance resistor out. But then if I did that, somebody was gonna say I'm hiding imbalance in the box. Oh, people and their opinions. I swear. Get some test equipment. Double check my results. Okay, so here's our output combiner. Hello, 1, 2, 1, 2. No imbalance and over 1,000 watts. Hello, 1, 2. Like significantly over 1,000 watts. We just picked up 200 watts worth of output power by simply putting the right size wire to carry the current to the actual location that it's going to need to be utilized. But ching, mic drop. Just Just saying. Food for thought. I want to give this a bath yet because it's dusty on the inside. I want to wash that. I want to squirt some clear in it, and then I'm going to change out this balance resistor here to a 5-watt. So when he does have a problem, him being a truck driver and all, he can smell it. And he'll know he's got a problem, and he knows to stop keying a box, and he's going to save his $250 a piece Toshibas. Hello, 111111111111111. No imbalance. None. None. Okay. Sorry. I had a guy contact me earlier today about the 5 waters, and he went on and on and on and on. And I was like, dude, shh, calm down. All right, so I'm done venting that out of my system. This thing is tweaked up as best as we're going to get it. And we got 200 more watts out of the son of a gun just by making sure the current's not getting lost in the connections. If you guys were to take a voltmeter and measure from here to here and measure your voltage, and then measure from the case to just the distribution bar on the inside, not to mention what it's actually like down here at the transistor, you will see why bigger wire is better. Because the voltage drop is phenomenal across all these different connections, right? Going through the little tiny ferrite beads with the little tiny 18 gauge wire wrapped around them, that's like a whole volt that you're losing from here to here. So then you got all the mechanical connections that go from here down to the foot of the transistor. It's another like 1/4 of a volt, right? Just saying. I'll keep preaching it until I see other people adopt it. I've got almost every amp builder in the United States kind of converted over to my way of thinking. So eventually, the last 3 of the Mohicans will pick up a voltmeter and be like, oh God, he's right, son of a bitch. All right, so we finally got this all put back together. Got the clear on the cabinet. Now I was told specifically by the owner that I need to remember that this amplifier is going to go sit behind a completely separate wall from where he's at. So he said, and I quote, put the biggest and the baddest, gnarliest fan that you can on this thing. There it is. So I've got faster fans in this, way faster fans, but they don't work so hot in an RF environment. The little computers that makes the wiggly diggly go around in a circle, they don't like the RF environment. But 111, 1111111. That's with a 1 watt carrier and a variable all the way open. This thing's working like a Swiss watch. Fan don't slow down. Nothing changes. So now we're almost done with this song and dance and the poke and the joke. The only thing I got to do now is I've got to help this guy out with a couple supplies. So before I can wrap this song and dance up, I've got to take these 4 supplies apart, and I got to modify them for 15 volts apiece. So give me a minute, and let's get that finished too. Well, there we go, gentlemen. This is the end of this story for me. 4 switchers, modified, 1x4, completely modified. Got another 200 watts out of it. 667 that now does over 800 watts reliably all the time. Done and done, power wires and everything done on it. Now it's time to box this all up and send it back. Gentlemen, I don't know if you know this or not, but Penna Labs has changed their webpage. Now on checkout, you can enter into the promo code. Simply type in BBI, you'll get 10% off. Remember, if you're a new time purchaser from Penna, first time ever, they'll give you 15% discount. Big shout out to XS for letting us have access to the Max 90 12 volt battery, which is the most awesome 12 volt battery on the market. Shout out to MechMan, Siglent, Bird, of course, and Coaxial Dynamics. Our good friends over at Steaming Coax for the digital bird meter. On that note, I'm going to say, gentlemen, thank you. To my customer, I say thank you for sending these up and giving me the opportunity to go through them and play with them. I think you're going to be very happy with the end results. Remember, 1 watt, 1 watt. 30 watts peak, 30 watts peak. That's it. That's all you ever want to put into these. On that note, I say thank you to the Patreons for letting us have 1 hour worth of uninterrupted, non-commercial YouTube content to watch. I hate YouTube. I hate it. And